Hello. Yeah. Good evening and good evening, everyone. So we'll start shortly. Let everyone join. Um, right, yeah. Whoever is joining, please. Yeah. Good evening. Good evening. Till then, please make sure you folks have you know, um, filled the attendance form. I think there has been attendance form which has been circulated already. Kindly make sure you um, fill the attendance form. Yeah. Hi everyone. Hi, good evening. So we'll start in some minutes. Let everyone join. I hope there is no background noise as well today. And, yeah, you guys have been able to follow whatever has been taught till now. Excuse me. Okay. So yeah, I think it's already time. Let's yeah, today's definitely a great day. Yeah, fine. Let's just start. Right. Let's start with the session. Right. We'll start from where we left yesterday. Right. I hope you guys have been able to follow whatever was taught. Whatever is covered in the session. Um, I'll share my screen. Right. So yesterday's assignment was basically to see what all you know joins does pandas offer to us. Right. We also saw how important and how good these joins are. Right. In the yesterday's session, we all saw how nicely we can use these joins to our advantage. Right. We saw how we can. Okay. I'll quickly recap as well. So we saw. Yeah, we saw different things. We saw how we can read and write a data, how we can like first how we can create a data set. Then we saw how we can so how we can create a data set. Then we saw how we can um, read a data set, right? The standard forms of from the standard file types. The CSV is one of the most standard file types in which stuff is circulated around. Tables are circulated around. Apart from that, we also have the XLSX file type, which is basically the Excel file type. So these are the most common file types in which these tables are circulated by people. So to be able to read that table into pandas, right? You need this read CSV. We also saw how we can see the table. So we saw two methods. One is df.head and the other is df.tail. Okay. Yeah. Um, so I hope you guys were able to download the data in either case. I'll anyways share it. So if you have the data downloaded, you just have to like drag it here, right? Um, you just have to drag it here, and this data gets loaded here. Uh, let me just oops. Yeah. So I shared the link of the data, right? From there you can download the data if you have not downloaded yet, right? So we start with import pandas as PD, and oops, we forgot to write as import pandas as PD. We read the data set, We print the, we display the head, we display the tail, right? We also saw how we can like display stuff, right? Apart from print function, we have this display function in which we can display stuff. We saw how we can access columns. We saw how we can access indices. Uh, we saw how we can like access a particular row, like here. So we can access a particular row by its index. So here we are trying to access the row at index 1. So for that do we use the lock functionality. We just type, you know, the identifier for the data frame or the variable name for the data frame dot lock square bracket. Inside it we write the index name. If we want to use the default index, which is the 0 1, the integral index, it starts from 0 and goes till length minus 1, we use the ilog functionality. Right. Now, since here, the index which we have specified is the same as the default index, therefore we see no change in code between lock and ilog. But then, yeah, we also saw we can like set a column into the index, right? We can take a column and set it to the index, and so this is how we do it, right? Set a column as the index, right? So now after setting it, we see the index has now been changed, right? The index is now being changed, and if we want to like access any row corresponding to an index, we use the lock functionality in the way which it is supposed to be used, right? df.log, enter the index, right? The index. So this is the index column, right? This entire thing is the index column. I hope you are able to see it. See my cursor. Yeah, I hope you guys are able to see my cursor. So yeah, one of the doubts I get is how we can make these tables, right? So if you want to make these tables, first the most simpler way is to like the first instance thought would be like download the table from somewhere, right? I posted the link. You can download it from there. If you want to make some custom table, you can make it through pandas as well. But the easier way would be to make it through Excel, right? Excel is the it's a very simple user friendly interface. I hope you are like aware of Excel. Just put the headers, right? I'll put sales and rev, and then just I'm I'm entering just some random values, right? So in this manner, I just created a table with some random values. If you want to now convert it into CSV, just press Control, just go to Save As, and in Save As, just save it. Here you can actually control how you save it. So save as type, just go to find the CSV thing, the .csv, and save it by any name you want. So in that manner, you can actually save a table. Create this CSV file like table. Um, so yeah, that's how you do it. That's the most simplest manner you do it. You can make it in pandas as well. We saw that yesterday. We'll shortly recap that as well. Right. So df.log this bagel. You access the row corresponding to the index name bagel. We also saw how we can conditionally access stuff. Right. So da dot size equal to large. So where the size is large and the shading is 4, we it gives you only those rows. If we can like also so this is and this is or, right? And we also saw how we can create new columns in it, right? We operated upon two different columns, exactly how we operate over numpy arrays, and we created a new column, right? We created a new column. The next is how we, okay, this display, this need not be written if the code is the last line. If the code is the last line, this display stuff is not to be written. You can just write df dot. We also saw we can access the shape of the table, like what is the shape, what is the number of rows, what are the number of columns, right? So gives 20 comma 10 for 20 rows and 10 columns, right? We also saw how we can like make a random column, okay, from a date. I mean, how we can make a new column from a custom data. Okay, this is like a custom data which we made. So this is a list. Okay, we replicated it 20 times to match the number of rows, and we added it to to the data frame. And now, as we display the data frame, you see we have this random column added to it. Right. Similarly, we could have had any list here. Like I can have something like you know one, two. I could have had any column, any data which you specify in the form of a list or a series or a NumPy array. It's added as a column. Moving forward, we saw this some special functions from NumPy, NumPy.random.random, which basically returns, it takes some parameters. This is called a keyword parameter, I already told. So this keyword argument, right? This keyword argument comes on after non-keyword arguments. Please, um, make sure when you call in. It's generally a keyword type argument comes after non-keyword type argument. These are called non-keyword type arguments, right? So we saw how we can like create a NumPy array of random numbers within some range. So this creates this function. This creates a. Let me just zoom over it so that you can see nicely. Yeah. So this function creates a NumPy array of size. I mean of dimension 40. Right. It creates a NumPy array of dimension 40, whose numbers are randomly selected between the range 0 and 4, 4 not included. Right. And so we also, used it very, smartly to actually make a list, right? Here we made a list which has like names selected randomly from this list. So we created a list which has names selected randomly out of this list, right? And this is here actually we made an entire column from, I mean, entire data frame from scratch, right? Here we made an entire data frame from scratch. Let me just execute it. We first defined the variable for the data frame. Um, right algorithm for the day for a data set. What right algorithm? Do you want to know like how exactly do you create a data set, or how you want to um, analyze a data set, like view or operate a data set, or something like that? I mean, honestly, I would say there is nothing right here. Like everything is right given that you are doing it with some intent of yours, right? So all any you can do anything. Like uh, there is nothing right here, honestly. Um, we might do some. I'll give an assignment today through which like you will be, getting some additional comfort with this pandas thing. But then there's as such there is like nothing. You know, things are not that hard coded here. Like there's nothing completely right, completely. Yeah, attendance link. Yeah, moderators, please circulate the attendance link. Let me just put it. Yeah. So Fine. So this is how we made a data frame yesterday. We made a data frame completely out of random values, right? We made a data frame completely out of random values. So every time you run this code, every time you'll see a new output. Just just saying, कि every time you run this code, every time you'll see a new output, because every time you run this np.random.random and stuff like that, you will see a new random list. Right? So let's just run this and see what we made for ourselves. Yeah, before running, you just have to make sure that you import all your libraries. Right. So let's just see what we made for ourselves. Yeah, this is again. I mean, we are repeating what I said. This is a completely random, randomly formed data table. Right. This is a completely randomly formed table. Collab is very good at user interface. It is showing me the entire table. Others, you can do the coding anywhere. They won't nowhere they show the entire table, honestly. So yeah, these are some perks you get when you like work with Collab. So here we created a complete data set, and then we like what we created another data set. So this was basically the jobs data set. So the a company has around 40 jobs. It randomly assigns those jobs to four of its employees. Ram, Sham, Sita, Geeta. It records how many hours it took them to complete a particular job, and what was the profit which was obtained from that job. Right. So it records it all these data. This is a very real data set. Like such data are recorded in companies for real. Um, so yeah. Then we proceeded with making a employee name data set, which consists all the employee details. Right. We added one more employee to this list, Aman. Right. So the assumption is that Aman was on a leave when all the remaining four were working. So then what we did was our objective was to find the what how much profit, total profit, a particular employee has earned, and what is his or her salary. Right. So how we proceeded with it is, first we saw a example of this new function, the new method called group by. So you just write the identifier of a data frame dot group by, call it, enter the column through which you want to group it. So then here you enter the column name which you want to access, and here you enter what aggregation operation you want to do over this column. So what this basically does is, in our previous table, let me just show you jobs. It collects first. It collects you know it collects data corresponding to different names. Since we are doing the group by for this column done by, what the pandas does is, let us say for Sita, it collects all the occurrences of Sita, and for that column uh, we are accessing the profit obtained. So it will collect all the profits obtained by Sita. It will collect all the occurrences of Sita, and from there it accesses the profit obtained column. So for all the occurrences of Sita, what is the profit obtained? So basically makes a vector, right, corresponding to Sita, which signifies what are all the profits obtained by Sita. It does that, does a similar operation for all the four employees, Ram, Sham, Sita, Geeta. And then what it does, for each employee, the vector it has collected, it finds the sum of it. The vector it has collected, it finds the sum of it, and this would give me what is the total profit earned by individual employees. I think we ran this. Yeah, yeah, we ran this. So it got changed. If you observe, it got changed from our previous table, because every time we create the table, since we are creating it from random values, Um, okay, fine. Yeah, I'm getting some very good doubts. Let's just okay. So I'm getting some very good doubts. Let's proceed with them. Um, we'll proceed with them in the later part of the yeah, session. Currently, let's see how to analyze the data. Later, we'll see how we can, do modeling and stuff. So, what here for what we are doing is done by employee name, grouped by employee name, summed over profits obtained. Then what we are trying to do, our primary objective was what? Our primary objective was to see which person, earned how much profit and how much are they being paid for it, right? So if there is a disparity between the profits which the person is earning and whatever salary you are actually giving to him or her, then as a manager, let us say, this data set is generally available to a manager. So as a manager, you should be alarmed. Like maybe you should give that person a hike or a raise. I mean, if someone is like earning for you more than what you providing them as a manager, you should either give him or her a hike, a raise, or a bonus, or something like that. Right. So how we can now correlate this? How we can match this stuff? Yeah. How we can match this stuff with what is the salary obtained by the individual. So we use something called the group by, right? So we use something called sorry, not the group by. We use something called joins. Okay, we use something called joins. So joins is done by pd dot merge. So this method, if you just hover over it, you see that collab gives you an entire detail of it. Okay, this is called documentation, right? This is called documentation for a function or for any code, right? I would strongly encourage you guys to Google the documentation for pandas, numpy, and read through them and see what are the capabilities of pandas. Like all the capabilities I might not be able to cover in this session since this is limited by time. uh, right, but honestly, what my personal opinion is, this is not something that can be learned. This is something which is practiced, right? So with that digression, let's get into the code here. So we are doing a join operation. This is done using this merge function. So we provide both the data frame, the jobs and the employee details, and we specify that we are doing a left join. Right, we are specifying that we are doing a left join, and for the left data frame, right? For the left data frame, we specify a column name done by, and for the right data frame, we specify a column name, right? Column name, right? So what it is basically doing is for jobs, right? For jobs, selects the column done by, and for each employee, right? It selects the you know uh, for each employee it selects em- employee detail table, and from there it retrieves the employee details. Like an employee detail table, it retrieves those employee details, which includes all the columns, and it just joins them. So it's like this is the original table and this was the other table. So from the other table, details were retrieved and were simply joined to the original table. Right. So this is what is called, join operation. So for it does a match between this done by column in jobs data frame and this name column in the employee details data frame. So it's basically doing a matching thing here. Right. So it is doing a matching here. Now, if I do a left join, okay, I'll remind you that the jobs data frame had only four employees because we said the Aman, the fifth employee, was out on a vacation when these four were working. So the jobs had only four employees. So when you do a left join, okay, when you do a left join, only the details of those four employees would be fetched from the employee details. So when you do the left join, only the details of those four employees will be fetched from employee details, right? So here you don't see, in this, this is the joined column. This is the joined, not the column, joined table, or in other words, the merged table. In merged table, you nowhere see the name of Aman, right? You nowhere see the name of Aman. Let us say I had done a right join. Let us say I had done a right join. So right join basically gives importance to the right data frame. Now when we run this, we see that let's go down, 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 down. Yeah. So even though the jobs had no entry for Aman, since the employee details had an entry for Aman, it joined employee details, that row corresponding to Aman from employee details to the row, to the jobs data frame. Now, since the jobs data frame didn't have any entry for Aman, all these remaining values are simply, yeah, yeah. So all these remaining values are simply been assigned a null value. Right? All these other values have been assigned a null value. So we can actually like play around with this even more. So let let me go to the place where I define the jobs you know data frame. I defined it here. Now let me have one more fellow here. Let me have one more fellow here named Arav. Right. Now this Arav, and the story behind Arav is he was working with them, right? He was working with them, but now he is not there in the company, so he has left the company. So his name is there in this jobs data frame, but his name is not there in the employee details data frame. So now what I'll do is I'll just change it to 5, and I'll leave the other thing same. So now let me just run this. Let me run this as well. So now you see that again this is a random data set, and we see that at some places, right, we have Arav as well now. So Shyam, Arav, Ram, Sita, Gita, right? So some places we have Arav as well now. Now since Arav is no more there with the company now, so you know I'll slice this. I'll use the feature of slicing, and I'll slice out first four names and add Aman to it, concatenate Aman to it. So this is, these are the current employees. So this is how we can use slicing. I ditched, I sliced out the first four employees and concatenated with Now this I will enter here while I'm making the employee details data set. Okay. So the procedure is same. pd.data frame, enter the column names. Employee EMP details. Employee details name is assigned first. Then salaries are assigned again some very random values. Then employee details age is assigned, right? Then gender is assigned again. All are random values. So it's, it's the same thing, right? I mean, we have the same mm, data frame which we had earlier. Now let me go to jobs.groupby. So in jobs.group by, I can see that, now we have the updated table as well, where we have the entry for Arav as well. Now let me just go to this merge thing. So in merge, I'll first write left join. Like I'll first do a left join, and since in the right table in the right table in the right data frame there was no entry for Arav, all these details for Arav have been left null, right? So at any point where we have Arav, right, all these details have been left as null values. If I do a right join, right, if I do a right join, right, if I do a right join, you won't see Arav at all, right? You won't see Arav at all because the now pandas has given importance to employee details, and employee details does not have the name Arav inside it. So it does the matching, right? Done by and name, it does this matching, and wherever it finds a name which is not there in this column, but there in this column, it ditches that, right? So you won't find any entry for Arav, but then there is an entry for Aman. So wherever it finds an entry for in this column which is not there in this column, it still adds it. It still adds it, but it has to leave this as null values, right? So this is the left and right join. Let's do inner join. So inner join, what it does? Let's see what it does. Now in inner join, you won't see Arav anywhere here. So inner join, as the name suggests, it does the matching, and if it finds the entry in either of the column which is not there in the other column, it just ditches that. And there is the outer join as well. Outer join, it considers everything. Like it considers everything. If Aman is there here, Aman is not there here, it still considers it. Arav is here, Arav is not there, it still considers it. Right. Now in our case, now since Arav is no more there in the company, we should do a right join. We should do a right join. In fact, not even a right join, since Aman was not there in the company. Aman was on a vacation. We should rather do a inner join. So we did a inner join. We'll store that, right? We'll store that into a variable. Now this inter has a new data frame. And what we now do is we group it by this done by column. So we group it by this column. And then what we see is we want to access both these columns. We want to access both these columns. Now, since salary is same for every entry of Geeta, the salary is 10,000 only. Every entry of Ram, the salary is 10,000 only. So we can safely calculate the mean of the salary, and that would say be the same, right? Like if for every entry of Geeta, the salary is 100. If I group by Geeta, I get the salary column grouped by Geeta, it will have only 10,000s only in it. So if I do a simple mean operation over it, it will give me the same 10,000 only. While for profits obtained, right? For profits obtained, I want to do a sum. So I use this ag function, this ag method, and I calculate for every employee what is the profit he or she has obtained and what is her or his salary, right? So now again we saw this Geeta and Ram both are like are the least paid, right? But they are generating the most amount of profits they are generating. So definitely, as a manager, you should like give a raise to Geeta or Ram, or give a bonus or something like that. Right. So this is the slight recap of yesterday, and I went into some additional details as well. There's one more function here. Let me just go there. Yeah. So we saw this all the merge function. There's one more thing called concat here. Now, if any one of you have like done some SQL coding, you might have seen something called a append there, right? So if you want to like add more rows to your data frame or add more columns to your data frame, right? Now we saw how we can add a new column, right? We saw how we can add a new column. It was very simple, right? But let us say like I have two data sets. Due to some reason, like they were huge data sets. So due to some reason, I had to like slice them and make two data set. It was a single data set, but since that was very huge, I had to slice it, like break it into two, and then give it to you as a user. Uh, right. Now, as a user, let us say that you have a reasonably good RAM. You can accommodate a huge data set as well in your RAM. So for ease of operation, what you would do is you would do concat. You would concat the two data sets. So naturally, for concating by rows, the two data sets have to have the same column names. So just make a list and put the two data frames there, right? df1 and df2 are the two data frames. The identifiers for two data frames, they should be defined beforehand. So this stacks the two data frames by rows. They have to have the same columns. And again, like if it was sliced by columns, if you specify this keyword argument axis equals to 1, it will stack it by columns. So it will stack the data, align the data frames side by side. Right. So again, I'll leave that on you to try. Apart from this, there is a index join like thing as well. This is again the same join operation. You can try that as well. Like, or maybe I'll just try it here. So I have two data frames, jobs and debt, emp debt, right? So I'll join jobs dot join emp debt, and on how I'll specify left join, and yeah, it gave me the left join. So it oh so yeah, let me just so how exactly it does is it you specify the left, but then in jobs, right, in jobs, you actually have to set this done by as the index. You can still set done by as the index, right? But then this would like create complications in your here. Like indices have to be it's generally thought that indices have to be unique. But then pandas does allow you to have like you know duplicate indices as well. That's fine with yeah, pandas. So what you have to do is you just do jobs dot set index, so that this done by column gets set as the index, and you join it with emp details, employee details. I'll also set an index here as name, right? So the merge operation, which was basically doing a join, was joining on the basis of the columns, right? You have to mention ki, okay, from this table this column has to match from this table ka this column. This join function does it uh, by matching the indices, right? So join function does it by matching the indices, right? So now yeah, it functioned in the right way. Join function does it by matching the indices. So this is faster actually. Join is faster than merge. If you like, people have been asking you what is the most optimal way here. So join is actually faster than the yeah, the merge operation. And yeah, let's now move to having been equipped with the knowledge of pandas and how we can analyze data sets using pandas. Let's move forward to data analysis, how we can analyze the data, right? So yeah, data analysis is the art of deriving insights from a set of information. um, it involves two-stage process. It involves two stages. One is pre-processing, the next is visualization. These are the two key processes involved in data analysis. Pre-processing is basically a set of operations which you do over the data, which before you can actually analyze. So you clean the data, like you remove the null values. Null values, you have to deal with null values. You do not always remove the null values. Um, you have to like deal with the erroneous values as well. It's a general practice to remove the null values, but like this, that's not always done. You can actually deal with null values in different ways as well. We'll see in the next slides how. It involves removing duplicates. Now, some places you like have to remove duplicates. Now, let us say that employee details was the table. Some reason you know In our case, it was hardly like 5 or 6 entries. Let us say you are working. This is for a company that has like 2,000 employees. So the table would have 2,000 entries, right? The table would have 2,000 entries. Now let us say uh, you know a human error resulted in the name Arab being entered 2 times. So it has like the details of Arab having been entered 2 times. So you have to like remove those duplicates. Now there are complications involved in it. Like Arab can have 2 different entries with 2 different salaries. Let us say Arab was initially there in the company with a different salary. He left. He again joined with now again with a different salary. Um, so you have due to some reason the previous entry was not removed. So you have the same name Arav might have the same job ID as well, but with a different, with 2 different salaries. So I mean, so there you actually have to like see, okay, the previous entry was supposed to be removed, which was not removed, right? So that's how before doing any operation, you like have to think. Excuse me. Next is sorting data types for columns. Now, excuse me. Yeah. So, yeah, we need to sort the data types of the columns as well. We have to ensure that there is correct data types for each column. Now, when this problem generally arrives is, let us say that, yeah. So this was our previous table, which we saw in the previous session. So we managed to remove one. We managed to remove one entry from there. Let's just ensure that it is there. Now, you see, these are all like integral data here, right? These are all integers. What I can do is I can like, not me, like because of some human error, something could have been like stored like this as well, right? So something could have been stored like this as well, right? So instead of 4, it is now a string. So when you read this data in pandas, this column would be assigned a data type of object, right? So this column would be assigned a data type of object. You can actually try this. Maybe you have this data. I had posted the link in the notebook. You can download it, open it in Excel, just can randomly change a entry and see key, and then read it of course with pandas and see what data type it is assigned. So in almost in all cases, this the data type which would be assigned to this is object. Now object is like I had said previously that all the columns in pandas are nothing but series data types. Series data types. Now series is derived from the NumPy arrays. NumPy arrays were supposed to be homogeneous, but then this is not a homogeneous container. This has integers as well as strings. So for these types of containers, both NumPy and correspondingly pandas have a very special data type called object. Now this object is very slow, and with object data type, you actually forgo all the speed advantages, the vectorized operation advantages you get with pandas and NumPy. So so these kinds of errors in your data frame would result in like reduction. I hope you are able to view it. I'll zoom it a bit. Right now, I think you. as are able to view it. So this small error in your data set, like this small error in your data set can significantly reduce the speed of computation. Let us say I have like multiple errors like this would like significantly reduce the speed of your computation. Now here it won't really matter because this is like a 20 row data set. You might have to deal with data sets as large as 10,000, 40,000, or even millions of rows. Right there, if you have such errors, it would be it would significantly, I mean, the change in the processing, the slowdown in processing would be significantly observed. So what you have to do is okay, let us say you you just observe the first 5 rows of this table. You can see that all these values are like, what, integral in nature. Yet you saw that this data type assigned to the shedding column has been object. Now, now that should strike something in your brain. Okay, definitely there is some error there. Somewhere there is some error, even if that error is intentionally done. Okay, uh, data was not available for shading. So for shedding, the data was not available. So wherever the data was not available, I just assigned na as a string. I assigned na as a string. Even that is like not supposed to be there. Somebody assigned na as a string. Now that is not supposed to be there. What you instead do is you convert it into a null value. Now this again improves the computation. So and yeah, so after you assign a null value, what you do is you simply delete that. Simply delete that, and the pandas automatically assigns a null value. What that would do is now this data type which pandas had previously inferred as object now becomes int maybe 64. Int 64 would be the data type assigned to this column. Now again this becomes fast as previous. Here as well, if you see like in between somewhere there is this 5 which is in a string format. You just go, you convert that. Sometimes you just have to do it like with hand only. So go and convert that into normal 5. So these are ways to sort the data types. These are ways to remove errors from your data frame so that you like there's no compromise with the speed. You have to sort the data types. You might have to sometimes do scaling and feature engineering, dimensionality reduction. These are stuff we'll see later in the session. Now these are like stuff which is primarily required for when you are doing some sort of machine learning, modeling. I'll just briefly go through the scaling stuff. Right? Why do we actually need to do scaling? Now let us say that I am I have one column. Okay, one column I have, which is the range of that column is from 0 to 1. Values in that column are between the range 0 to 1, and there is one more column which has like range 100 to 1000. Now naturally the other column, if you make some model, right? Make some model which is like dependent on the. We'll see later what exactly this thing like we'll get into the details later, but currently I'll just say ki, if you make any model naturally, any model you make, right, any model you make, there is a natural tendency of all machine learning and models to be biased towards larger columns, like columns with larger data in them. Right. So there is a natural tendency of all machine learning algorithms, all machine learning model to be biased towards columns with larger, data in them. There are some machine learning algorithms which do not get that biased, right? Like there are tree-based algorithms, but we'll see that later. But there is, in general, there is a natural tendency, even if not machine learning algorithm. Let us say you want to like, see it as a from your eyes only. Like you want to have a huge table and you just want to see the values through your eyes. Now it's generally more helpful, right? It's generally more helpful that to it's generally easier to compare columns which have like data in same range. So scaling is generally done to bring down the range of a column into a specific value, pre-specified values. The normalization is done like to bring the range to 0, 1. Standardization, we'll see later what it does. All this stuff we'll see later. Let's just go to, yeah. So these are the common methods available in pandas to do all these types of operations. So not only pandas, like this sklearn, this is a new library, scikit-learn. We'll see later what it means. Yeah. So yeah, this is just that was just concise notes for you guys to like whenever you want to remember something like that. So yeah, in data processing. So data processing, I already gave you some brief about it. What all are the steps which you should be following. Now let me get into some further details of it. Let's get into some statistics, right? So in statistics, right? Um, yeah, any column which we saw here, like for example, this profits obtained. This profit obtained has some values inside it, right? This profits obtained has some values inside it. It has a range. It has some range associated with it. With range is what is the minimum and maximum values. It has some central tendencies associated with it, the mean, median, mode, and it has like it is basic any. It's basically a set of values. Right? It is basically a set of values. So you can think of this profit obtained, this column, as actually a variable which identifies with a set of values. So a variable which identifies with a set of values is actually called a statistical variable. So in general, a statistical variable is something which is a special type of variable which identifies itself with a set of values. Right. Now there are four key types of statistical variables. One is called the nominal, the next ordinal, the next interval, and finally the ratio. Right. So nominal is a class type variable. Like in our jobs data frame, this done by column. Now this done by column can also be seen as a statistical variable. This done by column is called a nominal statistical variable. It has only like the values present in it, the values it identifies with are class nominal in nature, as the name suggests, are nominal in nature, or it's like class type variable. There are as we can see, five classes: Shyam, Arav, Ram, Sita, and Geeta, the five classes. So this statistical variable identifies with itself, identifies with a set of values which take which are actually which can be like five different classes. Values which can be five different classes. So any value in it can be is derived from those five different classes. So such a variable, such a statistical variable is called a nominal variable. So here this done by is called a nominal variable. There is one more thing called the ordinal variable. Now ordinal variable, like let us say we have something called reviews. Let us now there is this movie called Sayyara, right? So let us say we just pick random 40 people coming out of the theater and ask what rating they would give to this movie, rating from 1 to 4, 1 to 5, right? 1, 2, 3, 4, 5, any rating they can give. So we take those ratings from all the individual viewers, and we collect that ratings, and that becomes a set. So the variable associated with that set is called a ordinal variable. Now ordinal variable is what? Ordinal variable is the ordinal variable associates with a set of values where values can be ranked. So reviews are like 1, 2, 3, 4, 5. Now review 5 is actually higher than review 4. We know that. We can 4 is higher than 1. So we know that we are we can actually rank them. While previously we had this nominal variable, this Shyam, Arav, Ram, Sita, we cannot do any sort of ranking between them. Now Shyam is not higher than Arav, or Arav is not higher than Ram, right? There is no such um, method or metric through which we can rank them. So a nominal variable is something like a class type variable. An ordinal variable is again like a class type variable only, but here the classes can be ranked. Right, the classes can be ranked. So there are 5 reviews, and all the 5 reviews are like ranked data. Right. So that is called a ordinal variable. The next is interval variable. Now let us say like interval variable. I reside primarily in Mumbai, right? I was from IIT. IIT. So in IIT Bombay, when I was residing, there was an experimentation going where people were like collecting the temperature, like the daily temperature every day. What was the temperature? Like the mean temperature every day. So they were collecting this mean temperature. Let us say like that I had a variable, like a statistical variable, which had like 40 days of temperature in it. Right, temperature in degree Celsius. So temperature in degree Celsius, there are 40 temperatures in degree Celsius, 40 days. Now, in such a variable, right, in such a variable, the values take, the values now not on, you know, are not like limit. The values take from not from a limited class size, right? So the values take from a unlimited class size. Right? Temperatures can have like very high. There can be a very high temperature. There can be a very low temperature. And the next thing is the individual values are like separated from a very fixed interval. The interval now makes sense. Now let us say I have 20 degrees Celsius and I have 10 degrees Celsius as two values of temperature. If I subtract 20 degrees Celsius from 10 degrees Celsius, I get 10 degrees Celsius. Right. So the 10 degrees Celsius still makes some sense, right? While in the previous case, in the ordinal case, right, I had like 5 reviews, 1, 2, 3, 4, 5. Now if I subtract review 5, if I subtract review 4 from review 5, would that give me review 1? That wouldn't give me review 1, right? I mean, it basically does not make any sense. I'm subtracting reviews, like review 5, review 5 minus review 3. Does it give me review 2? It doesn't give me review 2. While in temperature case, if I subtract 30 degrees Celsius, from 50 degrees Celsius, I get 20 degrees Celsius. So in that case, the difference actually starts making sense. And if the difference makes sense, the interval makes sense. So I can actually define an interval between 30 and 50 degrees Celsius, right? And the same interval would be valid between 30 and 10 degrees Celsius, right? So interval type variable takes its data from a huge class, um, where addition and subtraction makes sense, right? So 10 plus subtraction makes sense. Similarly, addition also makes sense, right? 10 plus 20 is 30 degrees Celsius. 10 plus 20 is 10 Fahrenheit plus 20 Fahrenheit is 30 Fahrenheit, right? So interval, we saw what is interval. Next is what is ratio, right? What is ratio? Like ratio, we have like division and multiplication also starts making sense. So ratio is like, you know, ratio, the statistical ratio type statistical values derives itself from a infinite set which has supports division and multiplications as well. Like let us say mass, right? I have 2 kg. So 2 kg plus, if I add 2 kg with 2 kg, I get 4 kg, right? This makes sense. If I subtract 2 kg from 10 kg, I get 8 kg. That also makes sense. If I multiply 2 times 2 kg, so that double the mass. So double the mass, 2 times 2 kg gives me 4 kg. So it still makes sense, right? So like if I double a 2 kg, like if I have a 2 kg mass and I double it, I get the double value, right? I get 4 kg mass. I get the double mass. While in our previous case, the interval case, if I have like 40 degrees Celsius and I double it, will I get like double the heat? I don't get double the heat, right? Similarly, let us say take one more interval variable. Let us take it like or okay, let's ditch it. We have less time. Um, so a interval like temperature, we had like 40 degrees Celsius. If I take 80 degrees Celsius, two times of 40, would it does it make sense? Like 80 degrees Celsius is not twice as hot as 40 degrees Celsius. You know, like that is a sort of a fact, right? 80 degrees Celsius is not twice as hot as 40 degrees Celsius. Heat is, if you have like studied thermodynamics, heat is something like which is not very correlated with temperature. Temperature might be sort of an indication with heat, but there can be stuffs which are like less you know temperature wise they are less hot, but then they are actually very hot. So in ratio, division and multiplication also starts making sense. So ratio variable takes its values from a from a infinite class where division and multiplication also make sense. So like of course we saw mass. And since division and multiplication starts making sense, there is something called an absolute zero as well in ratio. In ratio, we can define something called an absolute zero. So that basically summarizes the the four types of statistical variable. Now think of it like the now start thinking about what kind of data processing you can do on all these four types of statistical variable. Let us say you have a nominal variable absent. Like in this table, I have this done by. At one point I just forgot to add, Sita had done it, I forgot to add her name in. So can I like do anything now? It's just a information which is absent there. Like Sita was supposed to be um, doing some work, but I didn't record it, so it is simply a information absent from them. Now let us say I have this previous let us say my manager actually equally divided the work among all the five candidates. If he did it equally among all five candidates, then I know that okay, see, five of them would have had equal number of jobs assigned to them. So in that condition, if like one of the entries like Sita was absent, like one of the entries for Sita was like absent, um, I could have like I could have like calculated okay, there were about 40 jobs and there were about five people. So all the 40 jobs had to be assigned equally to all five of them. So for each individual, I should have like a count of eight. But if Sita's name is not here, this is a null value. I would have for Sita, I would have a count of seven. So then I can just see okay, this null value is no one but Sita. But let us say I had like two absentees. I had Ram as well as Sita absent. Like in both these, I had a null value for Sita as well as for Ram. Now, when I even with the previous assumption, I would still have a problem at my hand. Okay, I know there was something absent for Sita, there was something absent for Ram, but I don't know who has done which job. Like Ram had done this or Sita had done this. So in these cases, like this is the information which is absent. So when an information is absent, you like have actually you don't have any choice but to ditch the rows. Like you either just ditch the rows, or you like take okay, this here I assign Sita, here I assign Ram, because you sometimes you cannot simply ditch a row. Like okay, Sita did a job which provided a huge profit to my company. I cannot simply just ditch this. So what I'll instead do is I'll assign Sita here, I'll assign Ram here, and the hours taken I'll just take the mid value of it. So 3 and 4 I'll take 3.5 and assign it here. Or if I like know okay, this job takes this much hours, then I won't touch it. Instead what I'll do is in the profits obtained part, I'll take an average of it, and at both points I'll put the average value, right? So that uh, they, uh, it is like a better estimate of what is the total profits obtained by Sita and what is the total profit obtained by Ram. Right. Since I have a data missing, I can do such sort of operation. Um, like so, you do not always like remove missing data. You try to find it. You try to come up with some sort of you know some way to actually get some reasonable estimate of it. The next thing is removing duplicates. We already saw that. Sorting data types. So nominal is naturally, most of the time nominal is like object type data. Ordinal interval are mostly like, ordinal and interval are like mostly integral type data, and ratio is a floating point data, decimal data mostly. Interval can also be a floating point. Ordinal can also be a floating. I mean, floating point is generally not like I can have a class. Okay, in ordinal I can have like for reviews I took 1, 2, 3, 4, 5, but I could have taken reviews as 1.1, 2.1, 3.1, 4.1, 5.1 as well. So I can still have a floating point for ordinal. But let us say I took the review something like okay, um, or maybe not. Yeah, ignore that. Yeah, generally it is like it's a good practice. We have my laser pointer. It's a good practice that you maintain the data types. For nominal, you generally have object type, but you can always convert a nominal to a you know um, you can convert it from object to integer by assigning some random number to any class. Like let us say I had Sita, Ram, Sita, Gita, Sham. So I'll assign some random number to them, and now this nominal class, this nominal column becomes an integral data type. But nevertheless, like you get the idea. I think you get the idea. We'll proceed to scaling. Right, scaling is so much. All algorithms, in fact, even humans are like susceptible to failing to compare two columns when they have a different scale. So what we do is we generally try to scale the columns into a uniform range, right? So normalization, also called min-max scaling, is where you actually, the maximum value is assigned 1, the minimum value is assigned 0, and the remaining values are like assigned using this model, right? So whatever was the maximum, you subtract and so any value you subtract it from the maximum and divide it by the max minus min. Standardization is a slightly different way of scaling where you actually tinker with the background distribution. In standardization, what you do is you take the mean and standard deviation and simply just do this computation. Power scaling is like sometimes you might want to like so this is a part of feature engineering actually. Sometimes if you take the square root of a variable, this works very good with models. Sometimes taking square roots is very helpful. Logarithmic transformation, if your range is huge, like it starts from 1, it goes till 1 million, but it is very sparse. Sparse means okay, 1 to 1 million. It takes some value in between 100. It takes some value 10,000. It does not take value like 10,001. It does not take that kind of value. It takes like 100,000, 10,000, 1 million, that kind of value. So then it's a good idea to do this log transformation to reduce the range, right? So that you can like, it's easier for you to see as well. Next process is of course feature engineering. So feature engineering, we'll just go through two primary methods. This is a pandas method. This is a scikit-learn method. For scikit-learn, you have to proceed like this. For scikit-learn, you have to import sklearn as some value, whatever you need, right? Now sklearn might not always be like installed by default, so you do pip install scikit-learn, and this should install sklearn. Let's just see. Yeah, you when you see this kind of you know this kind of stuff, it means that it is already installed. So you import sklearn, right? And in, so sklearn has a submodule called preprocessing, which has this method called one not encoder. So let's just import sklearn dot preprocessing. I hope I'm writing the spelling correct. Preprocessing dot one hot encoder as let's name it as OHE, right? So this is how you can like import stuff from SQL. So let's get into what these means. So I previously told that you can convert a nominal variable. You can convert it into integers. Like you can assign some labels to it. Like in the previous case, like Ram, Sita, Geeta, Shyam, we assign them some numbers 1, 2, 3, 4. Like this is how you do it. Just let's just go see how it works. Done by this will return me the column, and I just use the get dummies. Oops, I sorry for the typo. Yeah, sorry for that. Yeah, so get dummies. What it does is it will show whether there is okay, what is there. Like this is a even newer way to show okay, who is here, who is there here. Like in the first case, in the first row, I think in the jobs column, the first row had Shyam. So here what it does is okay, here only Shyam was there. So the rest all it assigns false, and for Shyam only it assigns true. Right. In the next, there was Arav, so Arav was there. Rest all was were assigned false. Like sort of a label encoder. Like you cannot randomly assign some number, right? Instead, this is a better way to assign, convert them into some feature. So this is called feature engineering. Um, in one not encoding, what we do is we just for false we assign 0 and for true we assign 1. So that we convert them into integers. So the idea which I hope you're getting the idea. The idea is to convert this nominal data into into numbers. Now we cannot randomly convert it into numbers, right? There has to be some logic behind it. So a logical way is actually this get dummies or the one not encoding. So one not encoding, what we do is okay, for every label we assign an index, and when the label is when the label is there, we assign that as 1 and rest as 0. When 2 is there, we assign 1, rest as 0. When 1 is there, so this is how we do one not encoding. Let's proceed to data visualization. So with that we finish data pre-processing. We now move forward to data visualization. Now visualization, like Python has a very good library called matplotlib. So you import it by this statement, import matplotlib.pyplot as PLT, and then you actually start the data visualization. Right. So for data visualization, like you need a X vector, you need a Y vector, and then what you do is let's get into some examples. We first import matplotlib.pyplot. Sorry for the typo. We define X variable which has like simple numbers. We define a Y variable which contains the sign of X. Right? So if you remember the sign thing which we wrote, like NumPy has a default function for this sign function, and then we'll just do pl. Let's import it with some identifiers plt. So plt dot plot x comma y. You simply do this, and yeah, you see it has plotted something. You can see it has plotted something. Now generally it is a good way The recommended way is you first define a figure, and inside the figure you can actually define something called fig size. And fig size I'll define it as 3 comma 3, and then you plot it. You simply plot it, so you get a smaller. Now you can have like a huge thing as well. Like let me just do. You can have a huge, larger plot as well. Let's just do it like range 1 comma 40, and we have this. So now you can see this sign pattern. Right? Now the sign pattern is visible in a better way. Right. So this is how you do it. So this is some example of plotting in pyplot. Okay, matplot with pyplot. This is how you can plot it. If you like want to do it in a better way, if you remember the linspace command, like linspace, you just hover over it a bit, and Colab will automatically show you how you do it. So you start with a start argument, then a stop argument, then the number of you require, number of what is the dimension you require. So I start from 0, I end at, let us say I end at 2, and I need 40 numbers in between. So let's print key what I get. Yeah. So this is a small part. Let's say I need till, I have to print till, let's say 20, and I need 400 numbers in between. So I get a vector of dimension 400, and when I plot it, I get a very smooth curve. Right? So it plots from 0 to 20 only. Earlier we were plotting from 0 to 40. Now this plots from 0 to 20 only, but since there are 400 numbers in between, we get a very good resolution, and as a result a very smooth curve. So this is how you can like do some basic plotting in Python. There's this is called a line plot. These are some additional ways you can like tweak your plot so that you can have a, whatever. Um, so the plot you can actually tweak in your way so that you get a custom design in it. Like let's say I choose a line style in it. Like I choose a line style in it. I get, oops, didn't work. Yeah, the valid line styles are this. Yeah. So if I change the line style, I get a dotted line. So the double hyphen is for dotted line. The single hyphen is for single line. Now let me just enter something random so that I get the list of all the supported, line styles. So let me just try with this double dot, this colon. You see, yeah. So I get completely dotted. So you can actually play around with this and see, okay, what outputs you're getting. There is one more thing called a scatter plot. Right, a scatter plot is slightly different. Right, line plot, what it does is um, it plots the data. It plots the data, but makes a line in between them. Scatter plot just plots the data. It does not make a line. Right. So if I plot a scatter plot, plt plot scatter x comma y. So it does not make a line in between. So this is very important. I mean, this comes pretty handy sometimes. Now let us say like um, let us say I had some random, you know, plot. Let me go a little far. Let us say I had this random kind of plot. If I plotted a line plot, there would be a line in between every, dot. So that would be like a very, not a very good sight to see, honestly. So for this purpose, we have scatter plot. So there is bar graph as well. There is horizontal bar graph as well. Let's see how we can like do them. Let let me do a group by operation over my jobs. Sorry, over my jobs column, over my jobs data set, I'll do a group by operation over the done by column. Right. Yep. And I'll do a. I'll find what were the column names in jobs. The column names are hours taken. Let me find the hours taken. Oops. Let me go for the hours taken and see key what is the average hours taken by each individual employee. Now we see the average hour taken by each individual employee. We see Geeta has, mostly done jobs which were like taking less time. Like Geeta did mostly the jobs which were taking less time. So now let me also find the average revenue. Not the average revenue, the total revenue earned by each individual employee. Let me just go to the profit obtained, and instead of me, I'll just do ag. Inside ag, I'll specify a dictionary where I specify the hours taken has to be aggregated using me, and profit obtained has to be aggregated using sum. Right. So what is the average? So what is the average hours? You know, investor. What is the average hour by of the job, and what is the total profit obtained? So yeah, we saw ki yeah, Sita has been like spend doing the jobs which are requiring most number of hours, but then she could get very less profit. While Geeta has invested significantly less amount from Sita and still managed to get around the same profit. Uh, right. So yeah, Geeta was a little. You see that okay. I mean, on a lighter note, Geeta did like might have gotten a better work-life balance. But anyways, so this is how you can actually play around with data to see insights. These are called insights to which you obtain from data. Some other one more thing I can like obtain is let's also obtain the count. Let's also obtain the count. So let me just randomly. Okay, let me just randomly pick a column. Let me pick hours taken, and for along with me, I also find the count. Now I could have found this count for any of the other for any of the columns. I could have found the count. Right. I could have found count this for this profit obtained only. It could have given me the same one. So count is basically how many jobs were done by like whom. Arav did 8 jobs. See, Geeta did 6 jobs. Ram did 15 jobs. So naturally, Ram got a higher profit. Like Ram obtained a higher profit, a higher total profit because Ram did more number of jobs. While we can see that Arav could still get a very good profit at less number of jobs. Right. So yeah, these are some insights which you can derive. Now the objective here is to actually you know let's ditch the hours taken. Let's just do let's just find the total profit obtained by each individual. And so if you remember, if I do a values here, this will give me a numpy array for the column. Now I store this as my y, and my x is basically what jobs dot group by dot sum. Uh, right. So the done by is my index. So if I access the index, this gives me the index, right? This gives me a numpy array for the index. Now if I just assign it here, my x is the a numpy array consisting of all the names, while my y is a numpy array consisting of the total profit obtained. Now if I just do a plt dot bar x comma y, let's see what I obtain. What the Okay, please specify key which part you want me to explain again. But till then, let's just continue with where we were. We were trying to uh, we were trying to plot what is the total profit obtained, right? So in this manner, we can like plot it. Let's get we have a y having the values, the corresponding values. We have a x having the corresponding nominal names, nominal classes, right? And then we just shove it inside this bar function, and it gives you the output. You can also have a horizontal bar as well. Let me have a horizontal bar now. Let me see if I can plot this. plt.bar h, and we have a horizontal bar. We have a horizontal bar chart. Again, we can like you know do all the stuff we did before. We define a figure. Inside we define a fixed size, and in fixed size we define, let's say, 12 comma 3. So we get a very long chart. So this is these are some ways you can actually play around. So when you want to like create two different figures, you have to define a figure in between. Like if you don't define a figure, matplotlib by default defines a figure. But let us say like after this bar h, let me like plot it here. If I want to plot the bar and after that I want to plot a bar h, I should like, it's a general practice to define a figure in between, so that I get two figures. Right, I get two figures. For this, matplotlib by default defines a figure in backend. Yeah, how we can assign these x and y values. So what we did is we did this operation jobs dot group by done by, right. So this gives me a data frame. I mean, to be specific, series. This gave me a series. For a series, how we can access the how we can access these values as a numpy array. We just do as a values. So it gave me all the values as a numpy array. And for a series, how we can access these? So this done by is now the index here, right? If you do a group by, whichever column you pick, that column becomes the index of the the output, right? Whatever if the output is a series or a data frame, the index is this. Right? This column, the unique values become the index. So if I want to access the index now, what my objective here is key. I want to plot a bar graph whose x are basically the names of employees and the y is basically what is the profits they have obtained, the total profits which they have obtained. Now, how so x should be this. The index is my x, right, and the values are my y. So for getting the values, I just do this group by operation. I get the corresponding series, right? I get this series after doing the group by operation. And then if I want to access the values, I just do this dot values. If I want to access the index, right, this index is supposed to be my x. So I access it, we are using this dot index, right? So when I do a dot index, I get this index. This is an ND array only. This is an ND array, numpy array, right? So I hope that clears your doubt. We'll move to the next thing. If data visualization, some additional functions, additional visualizations which we can do. Histogram. So if you want to plot a histogram, if I want to plot a histogram, let us say in our previous column I had okay. jobs. I hope I have done it correctly. Yeah. In jobs, I have this column called hours taken. Now, let us say I want to plot a histogram of it. Histogram you generally plot for some, a continuous type variable. This hours taken is sort of a continuous type variable. I get the values out of it. It gives me an ND array of consisting of all the values. Now I shove it inside this plt.hist, and this should give me a histogram. Now, I'm not sure why it is taking so much time. Now here you can see some some arbitrary output. If you just do a plt.show, this arbitrary output would be gone. Yeah. So I get this histogram. This histogram means ki okay, between 1 and 2 how many jobs are there. So jobs between which take the duration, whose duration are between 1 and 2 hours, how many jobs are there? Whose duration are between 2 and 3, how many jobs are there? Whose duration are between 3 and 4, how many jobs are there? That's what it means. Um, for pie chart, this is what you are supposed to be making. So you have to enter the sizes, you have to enter the labels. Right? You have to enter the sizes, the labels. So pie chart is generally, done for a nominal variable. So let us say in our jobs data frame, we had this done by, sorry, yeah. So if I just do a group by over this, so jobs, I do a group by over done by. So yeah, I'm realizing that I'm running out of time, so I'll quickly end this session here. Jobs.group by done by, and do a, you know, I'll do, I'll access again the revenue. I'll make the same plot. I'll make the same plot which I made previously in the bar graph. I'll make a similar plot for pie charts. So I'll do a plt.pie, and inside it, the my sizes are basically the y. My sizes are basically y. Right? My sizes are basically y. So this sizes is basically the argument which it desires. You can you can have a keyword argument like this. You can have a keyword argument in case you like want to specify. Okay, this y is for sizes r. In case you don't, it still like assumes, since sizes is the first argument and you enter y as first, it assumes that y is for sizes. And labels are x. So let me just plot a pie chart for it. So you get a pie chart which shows the how much revenue, total revenue, who has obtained. Right. So this angle is automatically calculated by Python. And again, this drudgerous stuff is there. I can get rid of it by plt.show. Um, Even if I don't enter this label, this keyword argument, right? So these are the arguments which are supposed to be there. This is and the order of argument is like there. So the order of argument is first sizes, then labels. So I put y, then x. So y is supposed to be there for the sizes, x is supposed to be there for the labels. Labels is this, R of Sita Gita Ram. This is label. The size is used for calculating the angle of this pi. Even if I do this, this will still can't multiply. Okay, so it seems we cannot do this. So we'll do it the general way. Yeah, the labels equals to labels just go through. It is required to be gone through the documentation to see okay, what is the sequence of here? What is the sequence of arguments here? And if it gives an error, just revert back to sending this keyword arguments, right? There's something called a box and whisker plot. This box and whisker plot is slightly advanced type of visualization. Box and whisker plot, stack plot. I'll give that as an assignment now. okay, this box plot and stack plot. I'll give you a specific data set, and I'll also show you what is the code to plot this box plot. Your assignment would be to like um, try to plot a box plot and see what exactly it means. Um, there are these advanced. So yeah, there is one more library called Seaborn. So if you want to import it, you import it like this. Import Seaborn as SNS. Seaborn as SNS. So I mean, of course, this as SMS is optional. You can ditch it if you want to like write a Seaborn dot stuff. Um, so yeah, this Seaborn is slightly advanced visualization. You can try this. Like this is the same thing only. The same way we did all the computation. This heat map is slightly interesting. We'll see it in our next lecture, next session. In the next session, we'll see, yeah, how we can do some visualization using pandas as well. We can do some visualization using pandas as well. We'll see that. I think we saw that in the previous session, and we'll see how we can do the regression and classification. Right. Yeah. So we'll see how we can do this regression and classification in the next session, and we'll also do a small project, right? And that would conclude the bootcamp. Yeah. So this concludes today's session. Thank you for being there. Good night. A brief reminder to, yeah, this is for attendance for day 3. For attendance for day 4 is already, circulated. A brief reminder to um, just mark your attendance so that you get eligible for certificate. And again, there is the student program here, internship program. If you're interested, please do mark your interest in the form. Thank you and good night. So bye bye, folks. I hope you enjoyed the session. I'm ending it. Thank you.